Hello, my name is Greg Deckler, and I'm here along with Brian Julius for Enterprise DNA to present DAX is easy, calculate makes DAX hard, which is my tagline actually in the Power BI community forums. So before we get started though, I want to stress that if Calculate is working for you and you are using Calculate successfully today, this is by no means trying to convince you to adopt another approach. But if you're struggling with DAX or you're brand new to DAX, Brian and I think we've come up with a much easier method of creating DAX calculations that's far more intuitive and easier to learn than going down like the calculate approach, which I would describe as kind of like the traditional approach that people take with DAX. All right, so what do I mean by DAX is that calculate is hard or makes DAX hard? Well, I can say from personal experience, when I first started learning DAX 7 or 8 years ago, I really struggled with it. I would get really kind of crazy results and, my calculations would be, not always come out correctly. And had a really tough time understanding why sometimes, until I sort of abandoned calculate and started going down my own path on this. And that's why the book that I wrote, DAX Cookbook, about 3 years ago, it includes barely a mention of calculate or calculate table, anywhere within that book. And it has over 120 different DAX recipes. So the problem is that first off is that calculate is a very complex function. And I'll get into more of that on the next slide. And calculate almost forces you to adopt a star schema, or basically requires a star schema. Otherwise, a lot of things won't work. And I'll show you some examples of that. The other thing about calculate is it's this inside-outside programming model. Where you basically have to kind of start and build your calculation from the inside and then out. And it's not really intuitive. So most people prefer like more of a top-down programming style. And the last thing is that DAX is very hard to debug. And calculate makes DAX hard to debug because you really can't see what's going on inside of calculate. There's a lot going on inside calculate. The point, this is from SQLBI.com. This is basically the evaluation steps that calculate follows. I'm not going to read this wall of text that we have here, but if you're going to use calculate, you better read it all and you better understand it all. Otherwise, you're going to get yourself into trouble. So there's a lot going on, as you can see, within calculate. And you have basically no visibility to debug it at all in terms of what is going on inside of it. You just basically have to know. So the no-calculate approach. The no-calculate approach doesn't use calculate, as you might suspect, and it follows a very linear top-down structure. Utilizes a lot of vars or variables, and it more mirrors the way that we think in terms of a lot of times like programmers think in a very top-down kind of programming structure versus kind of inside-out side. And also actually mirrors exactly kind of how Power Query works as well, where each step creates a table and then you do something with that table at the end. So the other thing about no-calc, it's very repetitive. All your measures are going to basically work and act and look the same. So it can be a little bit more boring in that respect, I suppose. And because of each step is kind of captured in a var, it actually makes it very easy to debug. And Brian's going to go into that a little later. The final part about no-calculate is that you really only need to know or learn a handful of DAX functions to make you fully operational and pretty much be able to solve almost any problem you're going to come across with DAX. That includes like filter and add columns, summarize, distinct, select columns, and then your X aggregator functions like SumX and AverageX. And that's pretty much, if you know those functions, you can pretty much solve almost any problem you're going to encounter in DAX. Okay, so what about disadvantages? Well, as I mentioned, no-calculate is boring. I think Brian's pointed this out, that it's when you go down the no-calculate path, all your measures essentially look the same and they act the same and they work the same. And more importantly, they work. Context, you're not going to get away from context using no-calculate, still vitally important. And yes, you can still modify filter, context within the no-calculate approach. You can even do an all except without using a calculate. I have a video on that on my channel, Microsoft Hates Greg. One of the complaints that gets levied at the no-calculate approach that I've seen is that it's not, proper DAX. For whatever reason, calculate became, historically became the center of the DAX world. And so anything that doesn't use calculate, many people look at it as heresy almost. But I kind of liken this, maybe it's my engineering background, but I kind of liken this to the complaints that mathematicians would throw at engineers that would use things like numerical methods or Laplace transforms to solve differential equations. Because Laplace transforms and numerical methods made solving differential equations easy. But, it's not the proper way to solve a differential equation according to a mathematician. Well, because I'm an engineer, I suppose, whatever's proper to me is what gets me to the answer. And the no-calculate approach is still 100% DAX, despite what maybe some people would say. And then the last one that Brian's going to cover later on is, does it scale? Does the no-calculate approach scale to like tens of millions or hundreds of millions of records? And I'll let Brian cover that. But for now, let me jump into a few examples that I have here around how calculate can make things difficult or non-intuitive or give you wonky results and things like that. So here I have basically a date filter. It's just a date table. So I'm only using the date table here in this example. And so essentially what I want to be able to set this date here, the bottom date, to whatever date it is. And then I have a measure for beginning of month. So that's going to grab me the beginning of the month for what I've selected. So select a date just gives me whatever date the maximum date that's been selected. This calculates the beginning of the month. And if I was to write a days, so I will only want to return basically from this date until the beginning of the month, I'm going to return that number of days. So you might construct that similar to this in terms of calculate the count of the date, where you're filtering the dates from the, greater than the beginning of the month and less than selected date. But you get back wonky results. You get back 78. All right. Versus a no-calculate approach. And there's reasons for this I'm not going to go into, but it's all wrapped up in how calculate is operating within and what it's doing internally and when it's evaluating all of this. Versus the no-calculate approach. And this is how you create calculations without using calculate. Again, we grab in a var, we grab the beginning of the month, we grab the selected date, and then we use a table var. So we're just filtering all of the dates for the date that is greater than the beginning and less than the selected. And we do a count rows across that table. And that is right there is the basic structure of all no-calculate methods or code, if you will. You create some vars, you create a table var. You're probably going to filter that or summarize that table in some way. And then you do some kind of aggregation across that table, like a sum X or an average X, or in this case, count rows. And I return the result. And as you can see, I get back the proper value, 19 days. So that's a simple example. Another very interesting one is running total. And so here, this top one over here is using the standard quick measure for running total, which is this right here. So calculate sum, filter all selected is on or after the date. And that's your standard quick measure. If you use the quick measure to create a running total, that is the formula that you are going to get back. But as you can tell, because I'm only using, this is a single table data model, right? So in terms, I'm only using the columns from table in this case. So I'm using month as my x-axis, and I'm using my, that measure that came from the quick measure calculation. But you can tell that this is not a running total, and by any stretch of the imagination. So it's not, again, this is back to the point of calculate almost forces you into using a star schema, because it's going to give you really weird results when you're trying to do things across, a single table, if you will. Now, the opposite of that, or the no-calculate approach, is this one right here. So here I grab the max date that I have within context. I then create a table var where I filter all of the selected table where the date is less than the date, and then just do a sum X across it. And as you can see, it gives me back the proper running total, if you will. Okay, another example is this one right here. This one is the year-over-year change. And this one, you would, again, the quick measure would give you back this formula. Calculate sum of the value, does a date add where it subtracts 1 year. Then you divide the sum of the current value by the previous year, and then by the and so anyway, so that one gives back. And then I have another version of this. So this is using my date from my dates table. And then this one is using instead, the only difference here is that it's using the date hierarchy, date.date. But again, it becomes very dependent upon what you're using for your year. And in this case, if I use year from my table, then I don't get any results back for either of those measures. Now, if I use year from my dates table, then I get back one of them returns the correct value. But the one that uses the date hierarchy doesn't. And so the only way to get these both to work is to actually use the date from the year from your date hierarchy, and then both of those measures would work. Versus the no-calculate approach, which I just grab my max year, my sum x across all of the table where the year equals the year. That gives me my current value. The previous year's value is I sum x, same filter, where year though equals now year minus 1. And then I do the same calculation and it returns back the result. And that result is whether I use year from here, or I use year from my dates table, or even if I use year from my date hierarchy, it's always going to work. And even bonus, you don't even need to have a year column in your table if you don't want to. You could just have just a date, and I could just grab my year from my date and then calculate the current and then do the previous same deal where I'm just saying where year of date equals my year minus 1. So last example that I'll show, and then I'll turn this over to Brian, is this one is for lost customers, new customers, and returning customers. And I'll really just kind of focus in on lost customers, for example. This is the kind of calculation that you get. So if you're using calculate, right, you're doing a count rows and then a filter and then a calculate, and then you're doing another filter, and then there's your filter clauses. And it's, again, you can see it's very kind of, inside out. You have to build this thing. And then return new customers is very similar. Only this time you have 2 calculates involved. So you have double nested calculates. Good luck trying to figure out what's going on inside all of that. And then your returning customers, again, you're another very similar to the lost customers. You're doing count rows and then your filter, and then you calculate and filter, et cetera, et cetera. Versus the no-calculate approach, a little more verbose. But again, the same exact form. So I get my date is the max of the date. My churn date, I'm saying, 90 days. That's if they haven't bought in the last 90 days, then they're a lost customer. And then I can, again, use customers prior. I can say distinct, select columns, and then filter all the sales where the purchase date is less than that date. And that gives me my prior customers. And then my current customers, or, within the 90 days in that, is the customer list variable, which same exact, essentially calculation, except I'm doing purchase date where is greater than date minus the churn date and less than the current date. And then of course I get a table. I use except, where I essentially say, okay, give me all the customers prior, that aren't in customers list. And then that tells me how many customers I've lost by doing count rows across that table. And then the rest of these are very similar kind of calculations. So, as you can see, new customers, I've got it's almost the exact same calculation as before. And then my returning customers is, again, just has one more table, but it's essentially the same exact structure. And I have to do an except and an intersect and then count rows across my table. And as you can see, though, they would both return the exact same their values. So if I hover over these, the no-calculate and the lost customers, they return the same exact numbers. And same thing with this in terms of my new customers, and same thing with my returning customers. They all return the exact same information, whether you're using calculate or no-calculate. So is it proper DAX? Sure it is. It does give you the right answer? Sure it does. So that's my portion of the presentation. I'll turn it over to Brian and let him continue from here.
So I want to follow on to Greg's presentation with a discussion of two major topics. The first of which is visualizing and debugging no-calculate DAX. And the second of which is the question of does it scale? So one of the things we hear frequently in terms of criticism of the method is that it'll work for small data sets, but it will break down when you start using it on large data sets. And so we're gonna dig in and explore that question in depth. But what I wanted to do first was to talk about why I like this approach so much. And I've been using it almost exclusively for about the last 6 months. And the reason is really centered on kind of all the things Greg talked about in the first section, but kind of summed up best by an unlikely source. So this is an excerpt from a blog article by an expert named Greg Baldini. And to put it mildly, Greg is not a fan of this approach. But I actually think it's a really good article. I've put the URL for it in this slide. I think it's very well thought out, very well written. I don't agree with the final conclusion of it, but I think he really makes a great point in terms of why the approach is so attractive. And what he does is he equates it to Power Query in terms of generating a series of steps where each table represents a partial result. And why that is a really clear and easy to understand way of looking at problems. And so what I want to do was just briefly show you what that looks like in Power Query. So coinciding with the 6 months that I've been using the no-calculate approach, I've also been doing the nightly Excel BI challenges. And these are centered on Power Query and Excel. And this was a problem that came up just a couple of nights ago, and I can show you what the code looks like for my solution. And there are others who came up with more efficient solutions, but you look at this code and this kind of looks like a nightmare. And you think it would be really difficult to parse through and to debug something like this. But I would actually much rather debug code that looks like this in Power Query than debug a normal complex calculate DAX measure. And I'll show you why, which is what we can do in here is we can actually go through every single step. And if we click on the step, it'll show us what the sub-step result looks like. And even what we can do here is click in the empty space, and it'll show us as we drill down into each of the individual records what results those are producing. And so we can, kind of continue to click through, and all the way down to the end when we can get to the final result. And so it's very easy in Power Query, if you're getting an anomalous result that you don't understand, to figure out exactly where that's coming from and why you're getting it. And as I was thinking through this, I thought, wouldn't it be great if DAX let you do the same thing? And no-calculate DAX, in the way, as Greg explained it, that it kind of unwraps the outside into a series of intermediate tables and then aggregates at the end, it really lets you work like Power Query. And so one of the other things that is really key here is that in November of 2022, there was what I consider to be the best function that was added to Power BI that year. And it didn't get a lot of attention. I think a lot of folks thought, okay, it's interesting, but I don't really know what to do with it. And it's the toCSV function. And what it does is it converts the records of a table into a CSV text format. And that doesn't sound groundbreaking, but what it lets you do is it really lets you, for the first time, easily output the results of a measure that returns a table and visualize that easily within Power BI. And I'll show you exactly how this works. You've always been able to do this to some extent with either external tools, Tabular Editor 3 and DAX Studio, namely. And you could do it in the past using a combination of concatenate-x and unicar 10, which is the hard return. But it was kind of a kludgy workaround, and isn't nearly as robust and easy to use as 2CSV. I want to jump in and show you how this works, but if we just kind of talk through briefly, the 2CSV has 4 parameters. And the first is just the table that you want converted. The second is the max rows you want to show. So if you've got a virtual table, for example, that's 1,000 rows, it'll default to just showing the first 10. You can specify exactly how many rows you want to see, or what you can do is just put a -1 in there and it'll show you all the rows. Then you can specify the delimiter you want to use in your comma separated values in terms of whether you want it to be a comma, or what I typically do is I use a non-printing repeating space in order to kind of separate my columns in a nice visual style. And then you can also have it include the names of the headers, the names of the columns in the header or not. And we'll dive in and see exactly what this does, but I wanted to run through that first. So let's jump into Power BI in a couple of examples. So this first one comes from an analysis that I did with Mike Ford from the Austin Power BI user group. And what we did is we looked at the 25 days of DAX advent calendar challenge that Kerbal had posted about 1.5 years ago. And this had a whole series of kind of business-related measures based on the North Winds data set. And I thought it was a really good test of the calculate versus no calculate approach. And so in looking at this particular measure, this one just really jumps out as being a great one to show how the no calculate approach works and how the 2CSV approach is used to visualize these intermediate tables. So this measure specifically is focused on the number of customers who never bought a particular product, in this case, queso cabrales cheese. And if we look at the calculate version of this is a nice piece of coding by Mike. So it's not immediately clear how to debug this because it's all that outside in DAX, and there are no intermediate results that are kind of easily available. But if you look at the no calculate version, what you'll see something very different. What you'll see 3 intermediate tables and then an aggregation, in this case, account rows. And if we look at the logic of this, so we want how many customers have never bought a particular product. And I like to think about this in the context of a Venn diagram. And so if we think about this, we've got all of our customers, and that's indicated by the dark blue circle. And then we've got customers who bought queso cabrales, the product that we're targeting. And then the remaining area of that circle is customers who never bought. So if we basically can calculate the number of customers in the big circle and then subtract out the number of customers here, we'll get this number in terms of number who've never bought that product. And so that's exactly what the no calculate approach does. And if we jump back to Power BI, so what I want to do is I want to go through and visualize each of these tables. And let's do that using the 2CSV function. And so let me show you how that works. So I like to use the DAX Editor Pro editor designed by Greg. This is kind of my go-to DAX editor for a lot of reasons. It has a lot of features and functionality that I really like. So let's go to the day 14A measure, and here we go. And so what we want to do is we want to copy this measure, and we're going to call this all customers to CSV all customers. And what we're gonna do here is instead of returning the result, what we're gonna return is we're gonna return 2CSV and the first thing we want is the table. So that's going to be our all customer table. And then what we want to do is we want to return all the rows of that table. And we want to specify the delimiter. And as I say, what I like to do is kind of space that out using non-printing spaces. So we could say comma here, but what I like to do typically is use repeat, which is the character repeat DAX command, and then unicar 127, which is the non-printing space, and then just repeat that 10 times as our delimiter. And then let's put false for the headers. And typically, I like to put false here just because true, again, creates kind of spacing problems. So let's save this and let's see what this looks like. Okay, so that's successfully created. And before we go in to see this, what we can do now is we can easily create copies here, which is, so instead of 2CSV all customers, what we want now is the 2CSV for our queso customers. And then all we have to do is we use the same 2CSV template, but we just change the table to our queso customers. And let's save that one. And now let's create a third table, which is just going to be our never queso customers. And we just have to go here and change this to never queso. And save that. Okay. So now what we've got is if we close this down, we've got 3 2CSV measures. And so if we scroll down and look at these, so here, let's take the all measure and let's drop that into a table. And let's do the same with the queso customers and the never queso customers. And we'll look at these in sequence. And so what we can see here is, in this case, it just gives us a one column result, and it gives us all of the customers. Now what I've done is I've cut this data set down from like 2,000 records to 20, just to make it easy to visualize the results here without having to scroll. But the concept is exactly the same. And so what we've got here is we've got a list of all of our unique customers. And one of the cool things you can do with 2CSV, I'll show you a DAX trick that I like, which is for this table right here, the all customers table, what I typically do is if I'm working with counts, is I use the union function, and then I just combine that all customers list with a measure to count the number of records in that all customers list. And because that returns a scalar, we have to put it in brackets so that it becomes a one cell table function. And if we do that, then what you'll see is it's the exact same column of customers. But then what you'll get is at the very end, you'll get a count of the number of records in that list. So that's a helpful way I find of just glancing at this without having to count through explicitly. And that particularly is helpful when you've got a long list. And so we've got all of our unique customers here, which is 15. We've got our queso customers, and we can see that because we've got the customers and the product number, queso, which is 11. And we've got two customers here. And so what we should see in the final table, which is the never queso customers, is this minus this. And that's exactly what we do see. And that's the 13 that we get in the final result. And so one of the things that is incredibly useful about this 2CSV function is that it operates in context. And what I mean by that is if you were using Tabular Editor or you were using DAX Studio and you wanted to basically visualize these intermediate tables, that'll work. And that's the way I've been doing it for a long time before this 2CSV function came out. But the problem is that if you've got slicers on the page, when you visualize those queries outside of this context, you don't get the impact of those slicers. And you can simulate those slicers by setting variables or by using the alternate parameter of the selected value function. But those are all kind of kludgy ways to do it. This just operates beautifully. So if we look here and we trim the products down, it dynamically adjusts, and we can change this however we want, right in context, and have it recalculate with a different subset. And that is, again, kind of a beautiful functionality to have, particularly when we're looking at complex measures involving things like all selected, which are very hard to simulate outside of this context. So let me jump into a second example. So the next example is a customer churn example, and it's very similar to the one that Greg went through in the first part of this presentation. And if we again go back to the Venn diagram, what we're looking at here is 2022 to 2023. And we can visualize this churn process in the following way, that all customers is going to be the outline of both circles for both years. Now, if we have somebody who bought in 2022, but not in 2023, which is the blue, that's going to be a lost customer. A customer who bought in both years is going to be considered retained, and one that didn't buy in 2022, but bought in 2023 is a new customer. And we can see in Power BI, again, how this shakes out really exactly corresponding to the table measures. And so in this case, what we have is we want to look at how many customers haven't purchased anything in the current year. And so these are our lost customers. And basically, it again gets down to a 3-table temporary structure or interim structure, where we have all customers. We have a table that is the customers who didn't purchase anything in the current year, and then the subtraction of those two tables. And I've gone ahead and created the 2 CSV measures and just dropped those in. And you can see really this just, again, works perfectly in the sense that it gives us, for the first one, a list of the 15 unique customers in the data set who made purchases in either of the 2 years. The customers who only purchased, who made purchases in the current year, and then the subtraction of those two. And again, this is completely, dynamic based on the slicers in context. So we can move this around, and our numbers change dynamically along with the intermediate table measures that change dynamically as well. So if you go back and kind of look at Greg's example and how complex something like a churn measure is in the calculate context, and then you just look at it, really just how simple it is to just break it down in the no-calculate way, I think it's a really compelling example. So what I want to do now is I want to jump into the final question of, does this all scale for large data sets? So when Mike Ford and I did our original experiment with the 25 days of DAX no-calculate, what we got was we looked at the results for each measure and compared them in the performance analyzer. And what we found was that there was no statistical difference between the calculated and no calculated measures. And in fact, what Greg mentioned before was true in this case too, that the variance between the no calculated measure relative to the calculated measure was smaller, but no statistical difference in terms of speed. But then the question that kept getting asked by critics of the method was, yeah, sure, it works for small data sets, but it's not going to work for large data sets. It's going to break down. And this, when I mentioned Greg Baldini's article prior, that was his major critique as well. But the question is, if we really look at the data quantitatively, is that true? And so what I did is I did a poll on LinkedIn of Power BI users and asked, in the course of a typical month, how big is the largest data set you would typically work with in Power BI? And I think probably this overrepresents kind of expert users in the sense that I think probably the people who respond to LinkedIn polls, particularly on a weekend like this one was, are probably slightly different, let's say, than the average Power BI user. But let's just take this as a given. And so the result of this showed that about 3/4 of the users don't typically deal with data sets larger than 10 million. And so I took 10 million as the mark I was gonna test at. And what I did is I mocked up the data from 2,155 records to 10 million. And the challenge in that is you want to dramatically expand the fact table while maintaining the integrity of the dimension tables and relationships. And the way I did that was with a tool called Mockaroo. And Mockaroo is a pretty amazing way to simulate this in the sense that what you can do is you can upload your dimension tables, and then in the randomization of your fact table, you can pull fields, the key fields from those dimension tables. And that's what I did. And it really has a lot of options here. So in this case, for the key fields, I pulled randomly from the original dimension tables. For some of the fields here where there were blanks in the original data set, I created the same percentage of blanks in the mocked up data set. In addition, there's a whole set of formulas you can use to create mocked up data according to a particular distribution. Or in this case, with the discount measure, I created a custom list that pulled randomly from. And then what you can do is you can have that create up to, in the case of the plan that I have, up to 10 million rows in different formats. You can even create an API to pull from that mock data set. So I mocked that up and then looked at the performance in a number of different ways, through Performance Analyzer, through Michael Kowalski's report analyzer tool, and did this statistical analysis, the same statistical analysis that we did for the smaller data set. And this was a non-parametric comparison. And again, what we found mirrored exactly what we'd found in the two previous instances, which is that there was no statistical difference between the query timings of the no-calculate method versus the calculate method. And in fact, again, what you see here is a smaller variance among the no-calculate, which is again what you would expect because of the uniformity of the approach, that the measures just each time and time again look very, very similar and run very, very similarly. So you can't ever conclusively prove the null hypothesis. What you can only do is fail to reject it. So what you'll hear statisticians often say is evidence, that absence of evidence is not evidence of absence. So we can't say conclusively in every case that it won't break down, but what we can say is that for the examples we've looked at so far, even at the 10 million level, we're not seeing any sort of breakdown in the performance relative to calculate. So where does that leave us? So the next steps, I want to expand this out to say 100 million records or even potentially 1 billion records and just test this to see if there is any point at which it shows signs of breaking down, which we have not seen to date. Also want to run a larger sample size of measures and rigorously test the hypothesis that no-calculate results in a smaller variance of query timings. We want to publish and peer review the statistical analysis and also examine the query plans to better understand how no-calculate and traditional DAX perform at large scale. And finally, we want to develop training materials for this approach. That's something we're already working on, with this presentation being kind of an initial step in that. I also know Greg is working on a terrific series for beginners called DAX for Humans, and that is also going to examine this approach in depth from a beginner standpoint. So I hope that has sparked your curiosity at the very least. I think it is a really valuable technique. I think it is in many cases a much easier way to do DAX, a more intuitive way to do it. And so if you're struggling with DAX, I really encourage you to take a look at this. And even if you're not, I think it is an interesting approach for comparison. If you teach, I think there's always value in diversity of teaching approaches. And so, again, I hope that this has proved interesting and thought-provoking to you. Want to thank Greg for including me in this discussion. He is really the father of this approach, and I have really come to believe that it has tremendous value. So appreciate the opportunity to be here and present to you today, and look forward to talking about this in the future. So thanks very much for watching.